Hello. In this lesson, we begin with just a general overview of statistics and then define a lot of vocabulary concerning data classification and other statistical terms that will be used throughout upcoming lessons. So just a little bit of a lead-in discussing the importance of statistics. So almost every day you're exposed to statistics. Consider the following quotes found from various sources. Cardiovascular disease accounts for nearly 836,546 deaths in the U.S. That's approximately one of every three deaths in the United States, according to the American Heart Association. High blood pressure and diabetes are the main causes of kidney disease. Almost half of individuals with it also have diabetes and/or self-reported cardiovascular diseases, according to the National Institute of Diabetes and Digestive and Kidney Disease. Capital High had an average ACT reading score of 21.6 in 2016, and the state average was 20.8. That's according to the newspaper The Helena Independent Record. So by learning statistics, what you're really doing is you're developing the tools necessary to become an informed consumer, understand statistical studies, conduct statistical research, and sharpen your critical thinking skills. So there's a variety of benefits of studying statistics. To define statistics, statistics is a science of collecting, organizing, analyzing, and interpreting data in order to make decisions about a group, usually from a sample. So statistics is the study of data and what that data is telling us. Statistics is derived from the Latin word status, meaning state, when those in ancient Babylon, Egypt, and the Roman Empire collected data about matters concerning the state, such as births and deaths. That's where we get the word. Data definition is it consists of information coming from observations, counts, measurements, or responses. Examples, Google has 200 million searches per day. There are approximately 1,200 smoking-related deaths daily in the United States. Those are both data. When you're studying data, it's important to know that there are two types of data sets that we study. The first is the population. The population is the collection of all outcomes, responses, measurements, or counts that are of interest. It's what we really want to know. A sample is a subset or part of the population. It's a portion of the population. So the question then is, if we really want to know something about the population, why not just always study the population? Why use a sample? And the main reason is feasibility. Because of constraints such as time or money, are the main two, we usually can't study the population, or it might even be impossible, just too large. So what we do is we take a sample. We study part of the population and understand that part, and then we extrapolate and say that it's hopefully representative of the population. In the following studies, what we're going to do is we're going to read it and then just identify what the population and the sample is, be able to differentiate between the two. So situation number one. A researcher was interested in the effectiveness of a given learning program in preparing high school juniors nationwide for the ACT. So one school in each state was selected to participate in a test study. The population then would be what we want to know everything about, and what we want to know about is the ACT preparedness of every high school junior in the U.S. The population you can think about is everyone that was potentially able to be drawn from the sample. What do we want to know about? So every high school junior could have been sampled, and that's what we really want to know about. So the sample, though, would be those high school juniors selected for the study. It was those who were actually selected. Situation number two, a researcher is interested in the average number of hours of TV watched per week by children under the age of 5. So a sample of 100 children under the age of 5 is conducted using hospital birth records. So the population is anyone that could have been drawn. What are we trying to know? Well, we want to know about the number of hours watched by children under the age of 5. The population then would be children under 5 who who had a hospital birth record. And that's important in this case because if you didn't have a hospital birth record, you couldn't have been drawn. So you couldn't have been within the population because you couldn't have been drawn. So that is the population. Any children under the age of 5 who had a hospital birth record. And this happens a lot with cases involving children, because how do you randomly sample children? They don't go places, so you have to use records from hospitals. Are usually the number one place that people go. The sample then would be the 100 children selected. Last scenario, a high school principal is deciding whether the school should change its mascot, so she decides to survey some of the students. The population would be all students at the high school. They could have all been selected, potentially. So that's the population of interest. The sample would be those students the principal selected. However, she decided to sample, which we will discuss in upcoming topics. But that's the difference between population and sample. Population is the entire group that we want to study. Sample is the group that we actually study. Once we have differentiated between the groups, there's 2 vocab words that differentiate between the value that we obtain from those 2 groups, or that we want to know. The first is the parameter. The parameter is the measure that describes a characteristic of the population. You can remember it because parameter starts with P and population starts with P. So parameter is the value that we want to know about concerning the population. So we want to know it, but usually the population is so large we can't calculate it. So for example, if we wanted to know the average height of males in the United States, we would have to measure every single male. If it turned out to be 5'10", we would call that the parameter, 5 foot 10 inch. But we can't. It's too difficult, too many people. So what we do is we take a sample and we calculate that for the sample. And that value that we obtain for the sample we call the statistic. The statistic is the measure that describes a characteristic of a sample, which is being used to estimate the parameter. So for example, instead of trying to obtain every male in the US, I sample 100 males randomly and I find that the average sample is 5'9", we would call that the statistic. You can remember statistic because S begins statistic and sample, while P begins parameter and population. So they're the values that I'm using in calculating from the 2 groups. So just to differentiate between those. The goal in these are to decide whether the numerical value describes a population parameter or a sample statistic. The first one says, a recent survey of 80 college career centers reported that the average starting salary for engineering majors is $83,121. Because we only sampled 80 college career centers, and there are many, many more, this is just a subset of the population, so this is concerning a sample, and because it's a sample, this is a statistic. The statistic is the value of 83,121. Second scenario, the 2,182 students who accepted admission offers to Northwestern University in 2009 had an average SAT score of 1442. This actually is going to be a parameter because the group of interest is incoming freshmen, and the incoming freshmen were small enough that we could get everybody in the group, and we found that the average for the entire group was 1442 for average ACT scores. So that would be a parameter because the 2,182 was the entire population of interest of incoming freshmen. I'm going to give you a chance to try real quick. So, scenario for you is 30 registered nurses are selected in a survey from all hospitals in a 10-county area, and their average salary is determined to be $65,000. I'd like you to state the following. What is the sample? What is the population? What is a sample statistic? Or they would just say statistic. What is the population parameter? Or they would usually just say what is the parameter. Pause the video now. Come back after you've given it a chance to try. Okay, here we go, just to see how you did. In this case, the sample would be the 30 registered nurses that were selected. The population are all nurses in that 10-county area. The statistic is the average salary for those 30 sampled, so $65,000 is the statistic. The population parameter we don't know. It would be whatever the average salary is for all nurses in the 10-county area. And we don't know what that is, so we took a sample, but it would be whatever that value would be. Moving forward into talking about, now that we've differentiated between the types of groups that we look at in statistics, we should talk about the different types of statistics. And there are two major branches of statistics. First, we call descriptive statistics. That involves the organizing, summarizing, and displaying of data. So it's when we get data and we want to see what's going on, and so we make things like tables and charts and averages. That's descriptive statistics. Later on, we will look at what's called inferential statistics. That's when we involves using sample data to draw conclusions about a population. We want to understand the population, and so we use the sample in order to begin to understand what's going on with the population. So descriptive and inferential statistics. Inferential because we're trying to make inferences about the population. In terms of the two data, once you've gathered data, there are two types of data when you look at data sets. There's something we call qualitative data. That involves things like attributes or labels, or the key thing is it's a non-numerical entry. Things like if I asked every graduating senior after college what their major was, or I surveyed a bunch of high school students and I asked them what their hobbies were, or I took a sample of people and asked them what their hair color was. Those are all qualitative data. Quantitative data are numerical measurements or counts because they involve quantities. Things like if I ask people their age or their height or their weight. So those are all quantitative data. We're going to do an example where we differentiate between those two. So using the chart below, for the average salary of an optometrist, someone who studies eyes, state which data is qualitative, which is quantitative, which part is descriptive, and what inferences can be drawn from the study. So the qualitative aspect of this would be the gender. When categorized into male and female, the quantitative would be the average salary. That is a quantity that was calculated. The descriptive aspect of this would be the entire chart that tells the story. And the inference from the chart that I can draw is that it appears there's some type of gender bias. So males have a higher average salary than females, and so this chart is showing that there may be some type of gender bias. Later on, when you use inferential statistics, you can determine if that's true based on the probability of that actually occurring based on or compared to natural differences. So for right now, though, we would just say maybe gender bias. It appears there could be a strong case. I mean, that's almost $50,000. So last chance I'm going to give you is to try a situation where you differentiate between qualitative and quantitative data and the inferences. So the base prices of several vehicles are shown in the table. Which data are qualitative, which are quantitative, and then what inferences can be drawn. So pause the video now and then come back just to see how you did. Okay, real quick, the qualitative data would be the model of the cars. The quantitative would be the suggested retail. So retail price. The inferences that can be drawn from this mostly are, it's comparing hybrid cars and non-hybrid cars, and it appears that hybrid costs more. So that would be the inferences that can be drawn from this chart. And that concludes our look at overview and data classification. Thank you very much. Have a good day and stay curious.